In this question, a scientist is investigating a fictional reversible reaction involving fictional substances Q3G, D, QD, and G at 642 Kelvin. So again, we have this equation with that reversible reaction arrow showing our reaction can happen both forwards and backwards. Our first step is writing an expression for the equilibrium constant K for this reaction. Let's head to our reference sheet. Here's our equation for the equilibrium constant. In the top of our fraction, we're going to have the concentrations of our products to the powers of their coefficients multiplied together. And at the bottom of our fraction, we're going to have the concentrations of our reactants to the power of their coefficients multiplied together. Remember, only gases and solutions are included in the equilibrium constant equation. So let's start by looking at the top half of our fraction. That's our products. We've got QD, which is a gas. So that's going to appear in our equation. And it has a coefficient of 3. So that tells us we've got the concentration of QD to the power of 3. Next, we've got G, which is also a gas. So that again will appear in our equation. Coefficient is just 1. We've just got one of them. So we're going to multiply this by concentration of G to the power of 1. Remember, to the power of 1 is the same as the thing itself, so we don't need to include that. Then we're going to divide by, in our reactants, we've got Q3G. Again, it's a gas, so it can appear in our equilibrium constant expression. Again, it has a coefficient of 1. So we're going to have Q3G. That's to the power of 1, but to the power of 1 is the same as just the thing itself. And we're going to multiply that by, for D, which is also a gas, so it can appear in equilibrium constant, coefficient of 3, so it'll be to the power of 3. So here we've got the concentration of D to the power of 3. So there's our equilibrium constant expression. Let's find that here. QD cubed times G and Q3G times D cubed. Awesome. We're then told that a scientist initially adds Q3G and D to a previously empty container so that the concentration of Q3G is 2.53 molar and the concentration of D is 4.38 molar. So let's enter those givens into our table here. So the concentration of Q3G at the beginning is 2.53 molar. And the concentration of D is 4.38 molar. We're told it was a previously empty container, so these are both going to be 0. Next, we're told when the system reaches equilibrium, the concentration of G is 0.950 molar. So let's fill that in here. Awesome. Okay, so we now need to go ahead and fill in our ICE table. Remember, ICE stands for initial, change, and concentration. So our first step on doing that, after we get our givens, is to use our chemical equation to write algebraic expressions for the change in concentration of each of our substances. Now we're starting off with our reactants, with Q3G and D. We've got some of them at the beginning. So those are going to be turning into our products. So overall, the concentrations of our reactants are going to decrease, the concentrations of our products are going to increase. So I'm going to write an expression for each of those. So Q3G has a coefficient of 1. So that's going to decrease by 1x. 3D has a coefficient of 3. So that's going to decrease by 3x. In return, we're going to make some of our products. So we're going to increase our QD concentration by 3x because it's got a coefficient of 3. And we're going to increase our G concentration by just 1x because it has a coefficient of 1. So I'm going to go ahead and write those here on our table. Okay, so our next step is to pick the column where we have both our initial and equilibrium concentrations. That's going to be this column here. And I'm going to use that column to figure out what x is. So we know that we start with our initial concentration. If we add the change, which is x, we should end up with our equilibrium concentration, which is 0.95. So this equation is really easy to solve. we just end up with x is equal to 0.95. So there's our x. Now we can go ahead and use that to figure out our change in concentration for each thing. So for the concentration of Q3G, we've got negative x. X is 0.95, so that's just negative 0.95. For the concentration of D, we've got negative 3x, which is negative 3 times 0.95, which is negative 2.85. For QD, we've got plus 3x, so that's plus 3 times 0.95, which gets us 2.85. And we've got plus x for the concentration of G, so positive 0.95, or in other words, just 0.95. So let's go ahead and enter those numbers into our change in concentration row in our table. Negative 0.95 for Q3G, negative 2.85 for D, positive 2.85 for QD, and positive 0.95 for G. Remember, positive numbers do not need a positive sign when we enter them in answer boxes, but negative numbers do need a negative sign. All right, so finally we're ready to go ahead and calculate our equilibrium concentrations. To do that, we just take our initial and we add the change. So here we're going to have 2.53 minus 0.95. That's going to get us an answer of 1.58 molar. For D, we've got 4.38 minus 2.85. That's going to get us a concentration of 1.53 molar. And for QD, we've just got 0 plus 2.85. So the equilibrium concentration is just going to be 2.85. Awesome. Okay, so we've now got our expression for equilibrium constant and we've got our equilibrium concentrations. So now we can go ahead and calculate our equilibrium constant by entering in our equilibrium concentrations to our equilibrium constant equation. So we can go ahead and do that now. So for QD, the equilibrium concentration is 2.85. That's going to be to the power of 3. Multiplied by, for G, it's 0.95 equilibrium. Divided by, for Q3G, it's 1.58 at equilibrium, multiplied by the concentration of D, which is 1.53 equilibrium, to the power of 3. That gets us an answer of 3.89. So let's enter that down here to check we got that right. Awesome. And remember, equilibrium constant has no unit. Okay, so in these questions, we're starting out by writing the expression for the equilibrium constant for the equation that's given. Next, we're using the given information to fill out our ICE table with our known variables. We're then writing expressions for the change in concentration of each of our substances using the chemical equation and the coefficients of each compound to do that. We're then finding the column in our table where we know both the initial and equilibrium concentration, and we're solving to find what x is. We're then using the value that we calculate for x to calculate all our changes in concentrations, and finally we can find all our equilibrium concentrations by adding the initial and the change together. Lastly, we're going to take those equilibrium concentrations and plug them into our expression for K to calculate our equilibrium constant K for that reaction at the temperature given.